How can you predict strong Aurora Borealis displays? Imagine standing under a clear night sky, waiting for a spectacular light show that dances across the dark. Predicting when the northern lights will put on their brightest display is a fascinating mix of science and observation. The key lies in understanding space, whether and how it interacts with Earth's magnetic shield. Satellites floating about 1 million miles from our planet constantly monitor the solar wind, which is a stream of charged particles coming from the sun. When these particles have high speed and density, and especially when the magnetic field they carry points southward, it increases the chance of a powerful aurora. This southward magnetic field, called the BZ component, allows solar particles to more easily connect with Earth's magnetic field, sparking those vibrant light displays. These measurements can give us a warning just 15 to 45 minutes before the lights appear, making it possible to prepare for a show. Another important factor is the KP index, which measures disturbances in Earth's magnetic field caused by solar activity. When the KP index hits 5 or higher, it signals a geomagnetic storm, often leading to bright auroras visible even at lower latitudes. Watching for these indices helps forecast the likelihood of a strong display. Solar phenomena like coronal holes and coronal mass ejections also play a role. Coronal holes are dark patches on the sun that emit fast streams of solar wind. If these streams head toward Earth, they can trigger geomagnetic storms a few days later. Coronal mass ejections are massive bursts of solar plasma and magnetic fields that, if they hit Earth, can cause intense auroras. Tracking these features with solar observatories helps predict aurora activity hours or even days in advance. Scientists also use specialized models like the OVATION model, which takes real-time solar wind data to estimate where and how bright the auroras will be. These models produce forecasts for the next 30 to 90 minutes, showing the likely location and intensity of the lights. To improve your chances of seeing a strong aurora, check real-time aurora maps and alerts. Bright auroras often appear as luminous green bands, but they can also show shades of yellow, orange, or red during intense displays. The lights can be overhead or near the horizon, depending on their strength. Did you know that predicting these natural wonders relies heavily on satellites measuring solar wind conditions long before the particles reach Earth? When the solar wind suddenly turns more negative in the BZ component, it can spark a dazzling display within an hour. Even smaller solar events can produce visible auroras if the Earth's magnetic conditions are just right. By combining solar observations, geomagnetic data, and forecasting tools, scientists can give us a pretty good idea of when to look up and expect a spectacular show. So next time you plan to catch the northern lights, remember that science is making it easier than ever to anticipate their appearance and enjoy their natural beauty.